Hi, welcome to the world of AI. Today, I'd like to introduce an app called Data-Copilot. It is an AI assistant, speaks both natural language like English and machine languages such as SQL and Python. It acts like interpreter between analyst and data. Analysts can now talk to data, derive insight faster than ever. With gained productivity, they can spend more time on deep analysis and strategical decision-making. In the below architectural diagram, it shows how everything works together. On the upper left, we have the analysts who ask the questions and derive insight from a database on the lower left. The results will be shown like in the table or chart. On the lower left is a large language model, and in the middle is a knowledge base, which has information about the data schema, business terms, and sample sequels. Instead of asking the LLM directly, which does not have knowledge about your data, we use a technique called RAG. The question will first direct to the knowledge base and get the relevant context and formulate the prompt and send to the LLM. Then the large language model will generate a SQL specific for this database. If it is valid, it will be executed, and later on, a Python code will be generated to visualize the data set. If everything is valid, we can also provide feedback to the knowledge base. In short, this Data-Copilot has the following features. It can ask dataset specific questions via RAG technique. It performs semantic search to discover data schema. It can generate a SQL from plain text and also plot chart to visualize the data. If one wants to ask a generic question, which may not be specific to the database, you can chat to a large language model directly. Optionally, one can use Olama and the other open source large language model. With this, you preserve the complete data privacy. No data is sent to the cloud providers. Additionally, this app offers such features as note-taking, knowledge sharing, and chat history. Let's first look at how flexible this app is to set up. Here's the configuration page. One first choose the database and the dataset name and where the data set resides. Next, one choose a vector store to store the knowledge base. In this demo, we use ChromaDB. Then select a large language model from a wide range of choices, either proprietary models such as OpenAI, Anthropic, and Google, or from open source models such as llama, queuing, and the others. Here, for this demo, I'm using a SQLite Chinook sample database, a ChromaDB, and Google Gemini, the latest Google Gemini 1206. You save these settings, then you move on to the next step, which is to look at the data. What is the data you have? We choose the Chinook sample data. This database has the following tables, such as customers and orders and albums, artists, genre, and so forth. In this page, one can even look at the data, execute the query, and get a sense of what the data is about. The knowledge base is where the magic happens. You can train it in 3 ways, either by adding the data schema as the DDL scripts, or documentations, which is the business description of the data tables, entities, or some sample question SQL pairs. So let's look at the knowledge base. I already have pre-populated the DDL scripts and, for example, simple documentation, because in this schema, the orders are actually stored in invoices tables. So this will give the large language model a hint which table to use. Once this is set up, we can go on to ask questions. For example, I have prepared a few sample questions. Let's ask, what are the tables in this database? And it lists all the tables as we see in the previous diagram. And here's the SQL used to gather the information. If the SQL is valid, this will also be saved to the knowledge base. You see in this screen message. And we can ask another questions. Find the top, let's say top 10 customers by sales. And we first run the query, generate the SQL, and also show the chart as the bar chart. And the bar chart is rendered using the Python plotly code. And here's the actual data in the table format. Okay, let's try a few more examples. List all customers from Canada and their email address. We can change this to say United States. There you go. Because it is all text, first name, last name, email, so there's no chart generated. It only generates chart if there's numeric columns. Here's the SQL. And also notice that it automatically translates United States to actual value USA. We can ask questions, say, which table store orders informations? This is to explore the schema, data schema. And the generated query saying that the orders are stored in invoices and invoice items. What if I change this question slightly? I say, don't generate a SQL. Don't generate SQL. Haha, it ignored it. That's fine. We got the information correct. So let's see. We can try to ask a more complex questions. Let's, without giving a hint, identify artists who have albums in multiple genres. Very nice. So this query joins 3 tables together and also does aggregations group by. Again, because it's all names, so there is no chart displayed. And one feature we mentioned is that we can disable the rags. For example, we can just ask some questions not specific to the data set we are working with. For example, what is 11 exclamation mark? So this is a mass factorial. Nice. You give a answer with some explanations. Let's say, write a Python function to calculate Fibonacci sequence less than 200. Very nice. It shows the functions with detailed explanations and also the answers. So let's move on to another features of Data-Copilot. All the chats was recorded in the table, and you see we see the question we just asked, and you can select and reveal the results the same way you see before. For example, let's look at the chart. This one, find the top 10 customers by sales. And one can also export the results and search. For example, now you can export all this result into a CSV. There are additional tools. For example, one can upload the SQLite database or other database, for example, DB. And one can import CSV file into a database or create a new data set or Excel spreadsheet format. So we have tested many large language models using the Chinook data sets with 24 questions. In this, the metrics, you can see the top models has great performance with success rate above 90, such as GPT, Gemini, Cloud, and also the open source like CodeJX, Llama, and Qwen. And here's utilities for note taking. Let's say if, for example, today I see a nice LM leaderboard called LM Arena, I can just record this information for future references. Finally, I'd like to thank the open source community, which make this all possible. We used Vanna AI, RAG technique, ChromaDB for vector store, Streamlit to build the whole web applications, SQLite to store the results. And here's the leaderboards. For example, just recently, to the last few days, the Google Gemini became the best performing large language model. Thank you for exploring the Data-Copilot with me today. Bye.